Hi, welcome back to Leetcode. So in this video, I am going to discuss the second problem from today's weekly contest, that is integers with multiple sum of two cubes. So what is the problem statement? Problem is that you are given an integer n and integer x is considered good if there exist at least two distinct pairs a comma b such that a and b are positive integers, okay, and a less than equal to b, okay. So, and x equals to a cube plus b cube. Return an array containing all good integers less than or equal to n, sorted in ascending order. Okay. So that means, so what is they're trying to say, that we actually have some n, they will provide n. Now we have to find out any pair a comma b, okay, such that a greater than 0, both are actually positive, okay, b greater than 0, and we will add the cube of this sum of cube of these two numbers a and b, a cube plus b cube. Suppose we got x, so x should be less than equal to n. This should be actually the condition. Now, and also one more condition is the a less than b, less than equal to b, sorry, less than equal to b, okay, they're trying to say that. So this is the condition, first of all, that all the if there is any pair a comma b, both numbers should be actually positive, so greater than 0, a greater than 0, b greater than 0. Next condition is that a less than equal to b, next condition. So here there are two number a and b, so a should be less than equal to b. Third condition is that if we add the sum of the cube of these two numbers a cube plus b cube, we will find, suppose x is the sum of this cube cube of these numbers, so x should be less than equal to n. So if these three conditions actually satisfied, then actually we can say that this is actually a valid pair, good pair, actually kind of considered good. So we have to return an array containing all good integers less than or equal to n, okay, sorted in ascending order. That means in increasing order we have to return. Now in the increasing order, what, x, okay. Now an integer x is considered good if there exists at least two distinct pairs a comma b such that this condition is satisfied. So what they're trying to say, that suppose we one pair is a1 comma b1, okay. So this is true that a1 less than equal to b1, first condition. Second condition is that both are actually positive, okay. Third condition, suppose we got x equals to a1 cube plus b1 cube, okay. So this is one pair. Suppose we got another pair, that is b1 comma a2 comma b2, okay. Again same condition, a2 is less than equal to b2, a2 is positive, b2 is also positive. Third condition is what, suppose we got y equals to a2 cube plus b2 cube of b2, okay. Now this pair, these two pairs actually a good condition pair if this x equals to y. So if we found any at least two such pairs, or actually found the same x or same sum of the cube of these numbers, then we can say that this is actually a valid, good condition pair. So we will actually return x. This will be our answer. So let's see the example one. So suppose n is equal to 4104. 4104. This is n. Okay. Now they are trying to say that there are two such answer. Actually, I have 1729. Okay, 1729. So 1729. They are saying that this is one valid answer. Good condition pair. How? So we found actually one pair, that is actually 1 comma 12 and another was 9 comma 10, okay. Now let's see the first pair, that is 1 comma 12. So 1 is greater than 0, yes, 12 is also greater than 0, correct. So first condition is satisfied, that both are actually positive. Now they mention that a should be less, the first number should be less than equal to the second number. So 1 less than equal to 12, This is true. The third condition is that whatever the sum actually I have, that is actually the sum of the cube of these numbers, that is 1 cube plus 12 cube, that is actually 1729. So this is one pair. Okay, we cannot decide that this is actually our one possible answer. 1729 actually one possible answer. So how actually we can decide if we found another pair, distinct different pair, or actually we get the same sum of the cubes, then we can say that 1729 is one possible answer. Got it? So one possible pair is 9, 10. 9, 10. So 9, first question is that both should be actually positive. 9 is greater than 0, 10 is greater than 0. And A should be less than equal to B. So 9 should be less than equal to 10. This is true. Next is the cube of this 9 cube plus 10 cube. This should actually give me the same 1729. Okay. So you can see that we found two pairs. One is the 9, 10. Another is the 1, 12. For which you get the same sum. So we can say that this is our one possible answer. At least two such pair actually we should actually matched. At least two such pairs actually have the same sum. At least if there are multiple, like more than two, like three pairs actually have the same sum, then it is anyway it will be true. It will be anyway one possible answer. So that's why if we found at least two such pairs who actually have the same sum, then actually this will be our answer. Got it? So how actually we can solve this? So first of all, to satisfy that, so what is the first condition? First question is that A should be greater than 0 and B should be greater than 0. Both are actually positive, correct? So I know that this will be actually a pair. So there will be only two numbers, A comma B. So I can actually run a for loop, or actually A will start from 0. It can go up to max, whatever the max actually I actually have, and A plus plus. And we can run another nested for loop, or actually I'll fix the B. So now the second, this is to, here actually you can see that A is starting from 0. That means it cannot be actually negative, right? So we have actually fixed this issue, right? So B can start from 0 and B can go up to max and B plus plus. This is a nested for loop. In this outer for loop, we are fixing the first number of the pair, and in the nested for loop, we are actually fixing the B, the second number of the pair. Got it? So here actually you can say that we actually fixed the already validated the first condition, that both numbers should be positive. Here you can see that A can be only from 0 to max, positive, all actually positive. Here also nested for also B starting from 0, it can go up to max. This is also positive. So this condition is already satisfied. Now next condition is that A should be less than equal to B. So we can actually optimize this here. How? Here actually starting from B is equal to 0. So there will be some condition where actually our B is less than A. So that's why I will always start from B is equal to A. So now actually you can see that our B, the what of the value of B, that will be always greater than equals to A, because I am starting from A. Suppose 0, 0. This is A, this is B. Okay, next 0, 1. Next 0, 2. In this it will continue. So if I again actually completed this, suppose the first iteration, then actually I will go from 1, 1. Then 1, 2. Then 1, 3. Actually you can say that we have fixed the A now. Now it's changing the B. Got it? So this condition is now satisfied if we start from B is equal to A. Correct? Now third condition actually what is that? If I found any sum of these two numbers, A cube plus B cube. Okay, this number actually I have to check that do I actually have at least two pairs who actually have same X or same sum. So that's why we have to store somewhere in a map or set, anywhere actually can store that for this number, for this X or the pairs same sum, how many actually times, how many pairs actually I have seen, how many distinct pairs actually I have seen. So I'll store that. So in the map actually I can store that for this sum, so this is the pair actually I have seen, A comma B. I'll store. Suppose for this X, this is the pair A comma B. Okay, so I'll actually create all the combination whatever is possible, A comma B. Okay, in worst case, then actually what I'll do, I'll check, iterate this map. Okay, this is a sum. Okay, this is a sum I have seen. So do actually have at least two pairs who actually have the same sum. So I'll see that how many actually pair actually is, what is the size of these pairs, how many pairs I've seen for this current against this sum. So if the size is at least 2, greater than equals to 2, then this will be our answer. So I'll store into our answer. Got it? Answer will be stored into X. Got it? So now here you can see that max. Now you should think about that. What is the maximum value I should actually check? Right now, so they mention that X should be less than equal to N. Then actually this is a valid pair. Right now, just do some mathematical calculation. So I actually have AQ plus BQ. That should be less than equal to N. Correct? Because this is actually ultimately X. They mention that X should be less than equal to N. So X equals to A plus. So first of all, write X less than equal to N. So I've replaced X with AQ plus BQ. Got it? Now, what is the worst case actually? What actually can happen? That our both are actually same. AQ plus BQ both are actually same. Correct? So that will be 2 AQ. Okay. Otherwise, you can mention that just it is suppose AQ. Suppose AQ. Okay. And this is suppose 0. Suppose in worst case. So it is less than N. Correct? So what is the A value of A? A should be less than equal to cube root of N. Correct? A should be less than equal to cube root of N. So maximum value of A, it can go up to cube root of N. Clear? Similarly for B also, B can go up to cube root of N. So I can actually replace this max with cube root of N. Here also I can replace this max with cube root of N. Clear? Now go to the code. That will be easy to understand now. So first of all, find out what is the maximum value A can actually have or B can actually have. That is the cube root of N. So this is the inbuilt function in C++. So if I pass the N, so it will give me the what is the maximum cube root actually I can actually have. Okay, this is the maximum range. Now this is a vector of integer that I have to return in ascending order. Dimension, we have to return a vector of integer like good pair. So I ultimately have to return the X, right? Valid X. Now this is the answer I have to return, and now actually we need to store the, we need actually map to store that for this sum, what is the pair actually I have seen. So but another way you can say that for this sum, what pair actually created this sum actually. Okay, so that's why this integer is the key, the sum or X you can say, this is the X, and this is a set of pair. Why set of pair? Because they mention the multiple pair actually can create the same sum or same X. So that's why I need to store the multiple pairs. So that's why I need to store the unique pairs actually. So that's why I'll take the set of pair. Pair means A comma B, and this is the map. Okay, now just iterate this, create all the combination possible A comma B. So that's why A can start from 0 and it can go up to max. Max means cube root of N. I have already explained why cube root of N. Just observe this, because the suppose BQ value is maximum is 0. So that time it will be actually AQ less than equal to N, and it can go up to cube root of N. Clear? So this is actually the range for A. And next in the nested loop, I actually fix the B. And what is the range for this? So B will start from A, because they mentioned that A should be less than equal to B. That is B always greater than equals to A. In another way, actually we can say that. So that's why B will start from A, and it can go up to similar way, less than equal to maximum value B plus plus. Okay. Now actually I will generate the sum of the cubes. X. I'll generate the X. So A cube is equal to A into A into A. This is the cube of A, number A, and similarly for the BQ it will be B into B into B. And suppose this is the X equals to the sum of this number, sum of these cubes, AQ plus BQ. Clear? This is the X. Now mention that X should be less than equal to N. Then actually we'll consider this is a valid pair. So that's why if X less than equal is X greater than N, that means anyway in the next time, this is current pair is not a valid answer, that is correct, but in the next time if I increase the B, again our sum of this x will be increased, correct? Because this is clear, I think. So it is actually a comma b. So I'm increasing b plus plus. So if I suppose got 10 in one pair, so I got 10. The next time, next combination, I will get suppose 11, at least greater than equals to 10, because I'm increasing b. So aq plus bq, bq is also positive. So that's why it will be, our sum will be increased. So that's why I will break from that point of time. So that's why if our x is greater than n, so break from here. Anyway, this current pair is not an answer, but in the future also will not get any valid answer. So that's why I'll break from here. If it is a valid pair, so I'll store this for this current x, whatever the sum of these cubes. So store the current pair a comma b. Okay. So in this after this line number 17, we actually in this map actually have that for this sum, how many, like for any sum x, I can easily find out that which pair actually created this sum, right? Because from this map I'll store this sum x. So whatever actually pair actually created this sum, so I'll store this into the set, right? Now what I'll do, that I'll iterate on this map. Okay, iterate on this map. So in this map, first of all, I'll check that for this currents, what is the condition of a good x. Good x is that if the number of pairs that created this x, the sum, that should be greater than equals to 2, then we can consider this as our valid answer. So that's why I iterate on this map, and I'll see that how many in the set size. So in the set size, in the second value, it is stored this this set will be stored in the second value, second position. So in the second position, if the set size is greater than equals to 2, that means we actually have more than 2 pairs that actually have the same sum x. So that time this will be our answer. So I'll store this, whatever the I dot first x, I dot first is the first position. We are storing the sum of the cubes. So this will be our possible answer. So I'll store this into the answer vector that I'll return. Got it? And ultimately, after checking all the sum x, I will actually check that this is a valid answer or not, good x or not. So I'll return the answer vector. Got it? So what is the time velocity for this? So you can just say that okay, there are two nested for loop, so we can actually, it will give us TLE. But let's observe this. So what is the maximum value of max? So what is the n range of n? It is 10 to the power 9. Right. So cube root will be what? 10 to the power 3. So maximum value, it can go up to 10 to the power 3. Correct? Till now this is clear that our maximum range, it can go up to 10 to the 3. So there are two nested for loop. Okay. So one for loop is 10 to the power 3 for a. In the nested for loop, the range is again 10 to the power 3. So what is the total time complexity? It will be 10 to the power 6, because it is actually nested for loop. So that's why it will multiply a into b. So 10 to the power 3 into 10 to the 3, so it will 10 to the power 6. Okay. And we are inserting into this map. So map will take actually n log n, you can say that. So it will be actually, what is the n size? 10 to the 3 maximum. So 10 to the 3 into 10 to the 3, it will work, right? Ultimately, this for loop will run again on this map. So 10 to the 3. Got it? So ultimately, it will take actually 10 to the 3 into 10 to the 3 into log n. Correct? So that's why it is actually less than equal to 10 to the 8. So that's why it will actually work. I have shared this code in the description. You can check that. And if you have any doubt, any suggestion, you can comment on that. And if you're not yet subscribed, please subscribe channel. And also like the video. Thank you. See you in the next video. Bye bye.